Hey guys, let's continue with this idea of the parabola, and we're going to look at a couple different ideas of, well, they're transformations of our graph of f of x equals x squared. And now we're going to look at it as f of x equals ax squared. Okay, and when a is greater than 0 here, this definition, that means we have a parabola that opens upwards. Okay, as, say, this one does, f of x equals x squared, which is the graph I have here. In purple. Okay, now if, say, we want to perform a vertical stretch of our parent function, f of x equals x squared, then we'd have to have an a greater than 1. For example, we had the problem f of x equals 2x squared. Well, then we'd say we have a vertical stretch of 2. And notice it's out front and then multiplied by x squared. So let's just make a table and investigate what this looks like. X, y, and we're just going to do for now these same values each time. Okay, f of negative 2. 2 times negative 2 squared. Okay, which operation do we perform first? Do we multiply or exponents? Exponents, you got it. Negative 2 squared becomes positive 4 because negative 2 times negative 2 is positive 4. And then I'm going to multiply it by the 2 out front, 8. And say I did f of negative 1, at negative 1. 2 times negative 1 squared. What's negative 1 squared? 1, positive 1, multiplied by the 2 out front, 2. And then 0, I'm going to be at 0. And then if I plugged in these other values, I should see that they take that shape. Because, again, we've got the symmetry about our axis of symmetry, which is at the y-axis here. Okay, so if I were to graph this, negative 1, I'm at 2, 0, 0, 1, and then I'm way up here at 8. Let's just say that's 8, okay? Okay, and then I'm going to come down and up. Okay, so again, it's a U shape, not a V shape. Notice, a vertical stretch pulls the graph toward the y-axis. It stretches it towards the y-axis there, okay? Almost like it's stretched, taller and thinner, okay? And I might even put that here. Taller, thinner. Okay. So that would be a vertical stretch of a factor of 2 of our parent function, which was f of x equal to x squared. So this one again is f of x equals 2x squared. Okay. Okay, so now let's look, and remember that now both of these graphs we're going to show have this definition up here of a is greater than 0 that I'm circling here. But the one we just looked at was a greater than 1. And now let's look at, say, a between 0 and 1. Okay, with a between 0 and 1, we're going to have this idea of vertical shrink. And now remember, this top definition just means that it's a parabola that opens upwards, a greater than 0. And now we're breaking it into two ideas below that, which is a greater than 1 and then a between 1 and 0. Okay, let's look now at vertical shrink. Okay, let's continue and let's look now at, say, vertical shrink. And I'm just going to kind of erase what we did here, but I'll leave the graph on there. So remember, both of these are a greater than 0, but what we just did was a greater than 1. Okay, for example, here our a is 2. Okay. Okay. So now we're going to look at one with a between 0 and 1. Okay. So remember, both of these are a greater than 0. And including our parent, that's a greater than 0, but that's just 1, right? Okay. And I'll put this definition back up there here in a minute. Okay. For a greater than 0. So again, both of the ones and our parent 2 are a greater than 0. But now this one is a between 1 and 0. For example, maybe we had this one. And this is now a less than 1 and greater than 0. 1/2 x squared. Well, let's again make a table. And we're going to do our -2, -1, 0, 1, and 2. All right, f of -2. 1/2 -2 squared. What's -2 squared? +4 multiplied by 1/2, 2. And f of -1. 1/2 times -1 squared. But remember, we do the -1 squared first. -1 times -1 is +1. And then we multiply by 1/2. And if I plugged in my other values, I'd have 0, 1/2, and 2. Okay, let's go ahead and graph this. -2, I'm at 2. -1, I'm at 1/2. 0, 0, 1, 1/2, and then -2, 2. And then I'm going to go ahead and draw the shape. Okay, so notice, all three of these are parabolas that open upwards because they all have a greater than 0. Our parent, again, let me just do our parent and our parent colors here, was f of x equals x squared. And that's the darker purple one. And of course, a is 1 if it's not showing. If there's nothing in front of the x squared there, then it's 1. Now, our light blue one, remember, if we recollect, that was f of x equals 2x squared. And that we called a vertical stretch of 2. Stretch of 2, and vertical stretch made it taller and thinner towards the y-axis here, okay? Now, what happened here with vertical shrink in red? Well, vertical shrink, which is defined by an a coefficient of less than 1 and greater than 0, that then pulled it away from the y-axis. So in other words, it kind of flattened it and made it wider. In other words, vertical shrink pulled the graph of ax squared away from the y-axis. Okay, so vertical stretch pulls it towards the y-axis, and vertical shrink is going to pull it away from the y-axis. And again, that would be, say, f of x equals 1/2 x squared. So on all three of these, we have an a value greater than 0. And that's why they open up, is the term here. Our parabola opens upwards on all three. However, under that, you can have vertical shrink, which is a between 0 and 1, which is in red. Or you can have, and vertical shrink will flatten it and pull it away from the y-axis and towards the x-axis. And if you have, say, a greater than 1, then you have what's called vertical stretch like we do here in light blue, and that's going to pull it towards the y-axis. So vertical stretch pulls it towards the y-axis, vertical shrink pulls it away from the y-axis, and those are our two transformations that we're going to look at in this section.